All right, today we're going to go ahead and continue slope. All right, so last week we looked at slope two ways. All right, remember if we had a graph, we counted rise over run. So we looked at rise over run. Remember we counted up or down first and then left or right second. So that was our first way that we found slope. And remember that was when we were given a graph. The second way we found slope was when they gave us ordered pairs. We did our slope formula, y minus y over x minus x. All right, today we're going to look at our third way to find slope, and we're going to look at what happens when they give us a linear function, or they give us our linear equation of a line, y equals mx plus b. All right, remember the rate of change, or the slope, remains constant. All right, so here's the deal in that equation. For our linear equation of y equals mx plus b, you'll notice the m is in a different color. The m is our slope. The m is our slope. All right, now, you'll notice in parentheses it says that y must always be by itself. So, if y is by itself, we're going to take the number that's in the spot of the m, and that is our slope. All right, so remember the slope is right here. It's the m. Now, we can only tell slope if y is by itself. All right, so let's go down and look at some. All right, here's our first one. We have y equals 2/3 x plus 1. You'll notice we have y already by itself, so I'm going to take the number that's next to the x, which is 2 over 3. So our slope is 2/3. Let's look at the second one. Y equals 4x plus 19. Y is all by itself on one side, so I go ahead and I copy what's next to the x. Notice x is not part of my slope, only the term next to it. All right, the third one, y equals negative 1/4 x plus 1. The y is by itself, so we call it negative 1 over 4. All right, now, before we move on to some more of the challenging ones, let's go ahead and say I gave you this. Y equals x plus 3. My question is, what do you think the slope is? Take a second to answer it in your head. The y is by itself. All right, remember, the slope is the number that's next to the x. There's no number there, but technically we know there's a 1 there. So this would have a slope of 1. All right, now let's look at some problems where the y is not by itself. So here we go. Remember, we said the y has to be by itself. All right, if we don't have y by itself, we have to do some work first. Now, first, move the x over, and then divide by the number next to y. Now, when we write these, we want to keep them in order of our equation, and our equation technically says mx plus b. All right, so here we go. Let's try an example. First, I'm going to move the x over because our goal is to try to solve for y by itself. So to move that x, I'm going to have to do minus 4x on both sides. All right, now you'll notice I'm left with 3y equals. Now I want to write it in our form of y equals mx plus b, and I cannot combine these, so I'm going to copy the negative 4x first, because we have the x's first, and then I'm going to copy the positive 9. So first step is to move over the x and rewrite it in the order of our equation. Now I'm going to go back and I'm going to divide everything on both sides by 3. That will get those to cancel. I'll be left with y equals negative 4 over 3x plus 9 divided by 3 is 3. Last, I check to make sure that I can't reduce any fractions. I cannot, so I take the term next to the x, so my slope is negative 4 over 3. All right, so we got to get y by itself first. All right, let's go ahead and try another one of those. I have negative 3x minus 2y equals 8. Let's first move our x over, so I'm going to add 3x to both sides. All right, now I'm left with negative 2y equals, and remember we want to write the x first, so 3x and a positive 8. Now let's go back and divide everything by the number in front of y, so divide everything by negative 2. That will leave us with y equals 3 over negative 2x, and 8 divided by negative 2 is negative 4. All right, last I check, can I reduce my fraction? I cannot, so I copy it down for my slope. All right, so slope of the first one was negative 4/3. Slope of the second one was 3 over negative 2. All right, let's go ahead and try a couple of more, and then we'll have you practice some. All right, so here we go. Let's stay with our same pattern. First, I'm going to move my x over. So if I move my x over first, I'm going to subtract 2x from both sides of my equal sign. I'm left with 10y equals, remember we want to write the x first exactly how we see it. I have a negative 2x and I have a positive 6. Remember we want to keep it in the form like above. Now let's go back and divide both sides by 10 everywhere. Now here we go. I have y equals negative 2 over 10 x plus 6 over 10. They aren't perfect divisible, so I can't just divide them prettily. However, I notice I can reduce this. If I reduce that, I can divide both by 2, which would turn into negative 1 over 5x. And I can reduce this one. I can divide both of these by 2, which would reduce to positive 3 over 5. Now we have the y by itself, so let's go ahead and identify our slope. Our slope is the one next to the x, so our slope is negative 1 over 5. All right, let's go ahead and try one more, and then we're going to have you get into some practice. All right, here we go. First step, let's move over our x. Now notice it's a positive x, so I'm going to do minus x on both sides. That will leave us with 5y equals, remember we want to write the x first, and we have a positive 15. I'll go back and I'll divide everything on both sides by 5, which will leave me with y equals, remember that's a negative 1 in front of that x, 15 divided by 5 is 3. Well, if I copy down what's next to the x now, because I have y by itself, I get negative 1 over 5 for my slope. All right, so notice the patterns there. First, we moved our x over by either adding or subtracting. Then we went back and divided by what was ever next to the y, and we clean up and reduce any fractions, and then we copy the slope down from what's next to the x. All right, that's the last way to find slope. Now we're going to start to put it all together and look at some.